Welcome, dear learners. Today I will be discussing the concept of ecological footprint and understand how our lifestyles, consumption pattern, and energy use shape the planet's future. The concept of ecological footprint is a powerful sustainability indicator introduced in 1990s by Mathis Warangel and William Rees. It helps us to measure how much pressure human activities put on Earth's ecosystems by comparing our resources use with the planet's natural capacity to regenerate, known as biocapacity. In simple terms, it answers a crucial question: how much nature do we actually have, and how much are we consuming? By calculating our ecological footprint, we gain insights into whether we are living within Earth's limits or exceeding them, highlighting the urgency of sustainable living and responsible resource management. The ecological footprint is defined as the amount of biologically productive land and water needed to supply the resources a person, population, or activity consumes, and to absorb the waste it generates, all under current technological conditions. This includes everything from the food we eat and the energy we use to materials we consume daily. To make comparisons easier across countries and ecosystems, it is measured in global hectares. This standardized unit adjusts for differences in ecosystem productivity, allowing us to see how individuals' lifestyle or nation compare in terms of environmental demand. The ecological footprint is broken down into six major components, each representing a different types of human demand on nature. The first is the cropland footprint, which includes land used to grow food, animal feed, fiber, oil, crops, and products like rubber. The grazing land footprint covers pasture needed for livestock such as cattle, sheep, and goats, providing meat, dairy, and other animal-based products. The forest footprint accounts for demand on forest for timber, paper, and fuel wood. Similarly, the fishing grounds footprint measures the marine and freshwater ecosystems that supply fish and seafood. The build-up the build-up land footprints reflects the land converted into housing infrastructure and transportation network. Finally, carbon footprint, which today is the largest component, representing the forest area required to absorb carbon dioxide emissions from fossil fuel use after considering what oceans naturally absorb. Together, these categories reveal how much human activities draw Earth's resources. On the other hand, biocapacity refers to the ability of ecosystem to regenerate resources human consume and to absorb waste we generate, especially carbon dioxide. Just like ecological footprint, biocapacity is measured in global hectares, which allows us to compare the productive capacity of different ecosystems on a common scale. Several factors determine biocapacity. The first is the area of biologically productive land and sea, such as croplands, grazing areas, forests, and fishing grounds. The second is the productivity of ecosystems, which depend on natural conditions like soil fertility, rainfall, and climate, as well as technological improvements in agriculture or forestry. The final management practices play a major role. Sustainable farming, forest protection, and responsible fishing can enhance biocapacity while overuse and mismanagement degrade it. In short, biocapacity tells us how much nature is available to meet human needs, forming the critical baseline against ecological footprint are compared. On the other hand, ecological overshoot happens when humanity's ecological footprint is greater than Earth's capacity to regenerate resources and absorb waste, known as biocapacity. In simple terms, we are using nature fast than it can be renewed itself. Since the early 1970s, humanity has been in a state of overshoot. According to recent estimates, by 2020, we are consuming resources equivalent to 1.7 Earths, which means it could take almost two planets to sustain our current demand. The consequences of overshoot are visible worldwide. Forests are being cleared faster than they can regrow, leading to widespread deforestation. Many species are threatened or disappeared due to biodiversity loss. Fish stocks are declining as a result of overfishing. Productive land is deteriorating because of soil degradation, and the buildup of carbon dioxide in the atmosphere is driving climate change. Overshoot highlights the urgent need for sustainable living and resource efficiency to return within one planet's limit. The calculation of ecological footprint relies on large international data sets such as of those provided by United Nations, FAO, IEA, and IPCC. The process begins by estimating the per capita demand for different categories include food, fiber, energy, and built-up land. This demand is then translated into amount of biologically productive land and sea area required to meet it. Next, the values are adjusted into common measurement unit is called global hectare, which accounts for differences in ecosystem productivity worldwide. Once this conversion is complete, the ecological footprint can be directly compared to available per capita biocapacity. A simple formula helps us to illustrate the calculation. The footprint is equal to consumption divided by productivity per hectare. This method allows us to determine whether a person or a nation or humanity as a whole is living within Earth's ecological limits or placing unsustainable pressure on planet. The ecological footprint can be measured at three different scales. At the individual level, it reflects personal lifestyle choices such as diet, transportation method, household energy use, and overall consumption habits. At the national level, it compares a country's total ecological demand with its domestic capacity, showing whether it is living within its means or relying on resources from elsewhere. Finally, the global scale, it measures humanity's total demand against Earth's biocapacity. This global comparison reveals whether we are collectively overshooting the planet's regenerative capacity, highlighting the importance of sustainable choices at every scale. To better understand the ecological footprint, let us look at some global and national examples. In 2019, the global average footprint was about 2.7 global hectare per person. However, the planet's biocapacity was only about 1.6 global hectares per person. This gap is roughly 1.1 hectare, representing global overshoot, showing that humanity consumes far more than the Earth can regenerate. When we examine countries, the differences are even clearer. High-income nations such as United Nations and United Arab Emirates typically have footprint between 5 to 8 global hectare per person, reflecting high energy use and consumption. Middle-income countries include China and Brazil, range between 2 to 4 hectare per person. Meanwhile, low-income countries like India or Ethiopia often have footprints below 2 hectares per person. These comparisons highlight global inequality in resource use and show how lifestyle and development level shapes ecological demand. Now, the application of ecological footprint. ecological footprints have several important applications that make it a valuable tool for sustainability. First, it is widely used as a sustainability assessment tool, helping researchers and organizations understand whether human activities are within ecological limits. Policy makers also use it to set resource efficiency targets and design strategies for reducing environment pressure at national and regional levels. In the corporate world, it is increasingly applied in sustainability reporting, where companies evaluate the ecological impact of their operations. Another well-known application is its role in determining Earth Overshoot Day, the annual date when humanity's demand surpasses the planet's yearly regenerative capacity. Beyond these, the footprint serves as a powerful educational tool, raising awareness among students, communities, and general public about the consequences of unsustainable consumption and the urgent need to live within one planet's means. In this way, it bridges science, policy, business, and education. While the ecological footprint is a valuable sustainability indicator, it's not without criticism or limitations. One key issue is that it simplifies a very complex ecological process into a single metric, which may overlook important ecological dynamics. Another concern is its strong emphasis on carbon footprint, which, while important, can overshadow other pressing environmental pressures such as water scarcity, soil erosion, or toxic pollution. Additionally, the footprint does not finally account for the benefits of technological innovations, recycling practice, or ecosystem services like pollination, nutrient cycling, and water purification, which play a major role in maintaining environmental balance. There is also an ongoing debate about data accuracy and standardization, since different assumptions or calculation methods can produce slightly different results. Therefore, while the ecological footprint is a useful communication and assessment tool, it should be complemented with other indicators for a fuller picture of sustainability. Reducing the ecological footprint requires a mix of individual action, policy change, and global cooperation. A key step is energy transition, shifting from fossil fuels to renewable energy sources, improving energy efficiency, and cutting carbon emissions. Equally important is sustainable consumption, which include reducing meat intake, promoting plant-based diets, and choosing resource-efficient products. Waste reduction and recycling through circular economy approaches helps extend resource life and lower pressure on ecosystems. In transportation, adopting sustainable mobility options such as public transit, electric vehicles, cycling, and walking reduces both emissions and land use. Conservation practices like reforestation, soil restoration, and marine ecosystem protection threatens Earth's regenerative strengthens Earth's regenerative capacity. Finally, population stabilization through family planning, education, and healthcare ensures resource demand remains within ecological limits. Together, these strategies form a holistic pathway towards sustainability, allowing humans to move back within the planet's biocapacity and secure resource for future generation. To wrap up with, the ecological footprint serves as a powerful tool for measuring human sustainability, offering a clear picture of how our resources use compares to the Earth's capacity to regenerate them. Current trends show that humanity is consuming far beyond the planet's limits, creating ecological overshoot and threatening the well-being of future generations. This overconsumption leads to deforestation, biodiversity loss, climate change, soil degradation, and depletion of marine resources, emphasizing the urgent need for corrective action. To address these challenges, it is crucial to adopt sustainable lifestyle, including mindful consumption, energy efficiency, and low carbon living. Governments, corporations, and individuals must also embrace renewable energy sources, circular economy practices that minimize waste and maximize resource efficiency. By combining awareness, policy, technology, and behavior change, humanity can move back into regenerative capacity of one Earth, ensuring a healthier and more sustainable future for generations to come. Thank you for watching.